Alright, so we're gonna look at sketching of quadratics. So let me first just give you the very basic quadratic curve, that is y equals x squared. So y equals x squared is it's like a U shape and that's symmetrical. Okay, so something like this, right? I'm trying to make this as symmetric as possible. Alright, so the y equals x squared, the graph of y equals x squared looks like this. At 0 it is equal to 0, at 1 it is equal to 1, at negative 1 it is also equal to 1, at 2 it is equal to 4, at negative 2 it is also equal to 4, right? And so this y equals x squared curve is symmetric about the y-axis or the line x equals 0. Alright, so makes sense. Now let me say instead of x squared I attach a negative to there. So what does the graph of y equals negative x squared looks like? Well, 1 squared is 1. If I attach a negative to it, it becomes negative 1. And so what was 1 before, what before had the y value 1 will become negative 1, what before was 4 will become negative 4. And so we notice that the whole curve is simply just flipped, right? So at 1 this is negative 1, at negative 1 this is still negative 1, at 2 this is negative 4, at negative 2 this is negative 4. Alright, so now let's say I add a 1 to it, right? So negative x squared plus 1. Now what will really happen is that every value is just one more than what it was previously. So before, what happened was that at negative 2 you had negative 4. Now when I have negative 2 now, I will add 1 to it. So instead of negative 4 it will become negative 3. What was negative 1 before will now become negative 1 plus 1, which is 0. And so we notice that the whole curve is just shifted 1 unit upwards, right? This is 1 comma 0, this would be some value. Alright, this would in fact be negative 1 and 1. Alright, now one last thing. Let's say I attach a 2 here. So now instead of negative x squared plus 1 I have negative 2 x squared plus 1. What this will really do is this will make the curve steeper, because now the values will be more exaggerated, right? So they'll be scaled up by a factor of 2. So instead of being this spread out, it will be something that's more steeper, right? This will be some value that is less than 1, this will be some value, this will be some value that is more than negative 1, this will be some value that is less than 1. Alright, so now let's say I take the same thing. Actually, let me take the same thing, and instead now what I do is, instead of x I do x minus 3. And so what this will do is this will shift the whole curve 3 units to the right, and so my curve will look something like this, right? This is 1 comma 3, sorry, this is 3 comma 1, right? The reason being that previously, let's take x equals 0. Previously when I input 0 into this, I get 1. Now in order for me to get 0 again, since there's a minus 3 here, I would need to have 0 plus a 3, right? So 3 minus 3 whole squared plus 1, and I will get the same value 1. So in order to achieve the same y value, I need 3 more units of x, and so the whole curve is shifted 3 units to the right. Alright, now couple of things to notice here. First of all, when in the form ax minus b whole squared, that is the completed squared form, if your a is positive, it will be a U-shaped curve, as was the case here. If your, okay, so this is positive, if your A is negative, it will be an n-shaped curve or a sad face, as was the case here and so on. Right, so this is what the effect of A is. And also notice that if A is, let's say, 1, right, my curve looks something like this. If A is 2, my curve will be something that is steeper. If my A is half, my curve will be more spread out, and so on, more spread out. Alright, now the more important thing to notice is that since it's either a U-shaped or an N-shaped, every quadratic has a certain turning point. It has a certain maximum or a minimum, right? So here's a U-shaped, here's an N-shaped. It has a certain turning point that will either be a maximum or a minimum. If it's an N-shaped, this will be a maximum value. If it's a U-shaped, this will be a minimum value. And in fact, the coordinate of this is P comma Q in this form, right? I will tell you the reason of it later. And one more thing is that this quadratic is symmetrical about the turning point. So if I draw the line y equals q, if I draw the line x equals p, the left portion and the right portion will be equal. That is, they will be like mirror images or reflection. So if I take a look at 1 unit to the left of p, the y value will be the same if I look at 1 unit to the right of p. Because if I have something in the form, let's say ax minus p squared plus q, if my x is, let's say, p plus a 1, or if my x is p minus a 1. Okay, let me erase this stuff, or let me scroll a bit up over here. Right, so notice how both of these will give us a, well, p minus p is cancels out, so you get a 1 squared plus q, and in this case you get a minus 1 squared plus q. But since 1 squared and minus 1 squared is the same, both of these are equal. That is, both of these are just a plus q. And this happens for every value, and so it is symmetrical. Now, when x is equal to exactly p, you get a times p minus p plus a q, and so this is squared. This p minus p is 0, so you're just left with a q, right? And this is why this is the turning point, because at x equals p, you have the y value q. When x is not p, you have y equals q plus a times some value, right? And so this is why this is the turning point. Now let's take an actual example. Let's say y equals let's say 2x squared minus 10x plus 12. All right, and if I'm asked to sketch this, the first thing that will run through my mind is to complete squares to it. So x squared minus 5x minus 5 over 2, subtract the same thing, close bracket, plus 12. Alright, I get 2 times x minus 2.5 squared plus 12 minus 2 times 25 over 4. This will basically be negative 0.5. Now the use of this complete square form is that it tells us a couple of things. First of all, I noticed that the a, so let me write the general form over here. Right, I noticed that the a is positive, and hence it will be a U-shaped or a smiley face. And I also noticed that p is negative 2.5 and q is negative 0.5, and so my turning point, that is this value, this coordinate will be p comma q, which in this case is 2.5 comma negative 0.5. Alright, so let's make this. So far I know that negative 2.5 0.5. I know that this is a turning point, and I also know that this is the maximum value, that is, it's a U shape. Now, one more thing that I should take care of is to find the roots of this equation. So 2x squared minus 10x plus 12, the roots of any equation of a quadratic in specific is basically the points at which it intersects the x-axis. In short, it is the point at which y is equal to 0. So if I set this equal to 0, the x values which satisfy this, that is the x values which will give me the y value 0, will be the roots of the quadratic. Now this is something that you already know from before, how to solve this. Couple of ways: you can middle term break, or you can even complete squares and do it that way, or you could simply apply the quadratic formula b square minus 4ac over 2a. Here I notice that I can take the 2 out and I can middle term break this. So minus 2x minus 3x plus a 6 x minus 2 minus 3 x minus 2 equals 0, and so I get x minus 3 x minus 2. What I've done is I've factorized this quadratic. Now notice that when x is equal to 3, this is 0, and anything multiplied by 0 will give you 0. So one of the solutions is x equals 3, the other one by the same logic is x equals 2. So we got 3 comma 0 and 2 comma 0, that is this point and this point, right? And so now I can basically sketch my quadratic, and let's take this color. It will look something like this, right? Make sure to try to make it look symmetrical, something like this. All right, and that's all there is for today for sketching. See you then.